Okay, welcome to the second part or the second lesson for our introduction to C program design. We had given quite a lot of reference to what this code does. We want to proceed from that lesson that we had. So initially we have our variable, which we said was int m, and then we said we can display what we want to see using our printf. We also said our scanf gets the value that we want to put to our variable. So gets a value from keyboard. Printf displays what we want the user to output. At the same time, we said this gives us a value that we intend to use. Okay, so from there we can actually add more to what our current setup is. Okay, we can come here and on our line 9 we put a printf. Our printf then gives us the following. We want to be able to display the value of m. So we then say display value of m. Okay, we then put a new thing called a format specifier, where we put a percentage sign and we put a d. We put our new line. So this percentage d simply stands for a format specifier. So if we come this side, we then paste it and we say this is a format specifier. Okay, so the format specifier pretty much gives us the value that we're looking for. So to actually see our value, we need to put a comma and then we put our m so that we see what this format specifier does. So if I run the program again, you'll then be able to see I put my number as 56. Display the value of m now gives us 56. So what this simply means is we have simply created our variable called m. We've prompted the user to enter a number, which is that line. The user entered the number 56, and then we display the value of m, which is 56. So to be able to see this in a slightly different light, we can create another variable, and then this variable we call it character j. Then from there we can also do the same printf that we've got there in line 9. We copy it and we paste it just below our j, and then we want to change the variable and the format specifier so that we can see what each value gives us. So we can put j, which is our next value, and here we change this to j. And then our format specifier, we need to change it and put C. So C gives us our character values, D gives us our integer values. So if we rerun this program, we'll be able to then see what our J would be. So let's say we put 7 for our value. The value of M would then be 7. The value of J would then be blank, because the blank space can also be a character. So it then means at any given point in time, this is what we've got. So some of the notes to take note of at the moment is the following. We use percentage %C for characters. We use percentage %D for integers. Okay, but these are not the only options that we've got. We may have many other options that we might want to display or use as we are working with our code. So far, here's what we've got. We can also add the following, whereby we put a printf, and we want to tell the user that at this point we want to initialize the value of j. So initialize the value of j. So how we do that would be as follows. So we say j is equal to, we use single quotes and we put h so that we initialize the value of j. We can also copy this line as it is. We copy it and then we paste it. Okay. So after that, we can't run it whilst this console application is running. We need to close it and then we start again. So to start again, we need to put a number, and then now we'll be able to see the difference between the two options. The first thing that we've done, I'm sure you've been noticing with each run that we were doing, each number that we enter does not matter what kind of number it is, it will still give us the number that we've entered, and then we can be able to display the value of that variable, which is m. So m is equal to 8, which is the first variable that we've got. Display the value of j. At that particular point, j has no value whatsoever, so it gives us a plain answer. We have got our code in the right manner, but it will not give us a specific answer. And then when we say initialize the value of j, we then display the value of j as being h, which we have initialized at that particular point. So by saying j is equal to h, we have actually initialized the value of j to be equal to h. Okay, so initialization is the next element that we want to work with, where we are saying this simply assigns a value to the variable. So our variable will not have a assigned value, so to speak, which is why we then want to assign a value to it. So we have assigned j is equal to, in quotes, single quotes, we say is equal to h, like that. So in other words, we have actually initialized our j to be equal to h. We can also do the same for our m. So we can reassign our m and say m is equal to 43. That's the new value of m. So we can reassign the value of m to give us a new value outside of the one that we have entered. So let's actually do that and see how this works. So we want to print if, and our printf should give us the following: reassign the value of m. So to do that, we simply do exactly the same thing, where we say m is equal to 43, like we had discussed, and then we copy the value of m as it is there, and then we put it on the next line. Okay, so we can close this and see how our program works. So we can enter a number, which is 8, and then now we can see, as we display, we want to display the value of m, which is 8, the one that we entered. The next value for j is still blank. We want to display the value of j after we've initialized it. We get h. We want to reassign the value of m to 43. So in other words, the reassignment pretty much means we can still use the same variable with different values. So we then need to at least know, if we are working with a program, that our variable has been reassigned or has a specific value based on how we would have put our code together. Okay, so I think as of now we have pretty much gone through the basics of the intro, or the basics of an introductory project for our C. And in the next lesson we'll work with more content that we can add to our project or to our C, so that we can learn how we use certain attributes and aspects of our C to design and develop our projects. Okay, so from this project, let's create a new project which we will add more content. So this one will call it variables and operators. Okay, so we want to have an intro to our variables and our operators, where we'll have specific elements that we want to showcase and show you how they work. So outside of each element, we can create variables for different aspects. So for example, we can have our int I for our integer value. We can have our int, or rather our float, f for our float variable. We can have our double, d for our decimal variable. We can have our character, c for our character variable. Okay, so what this then means, these are the primary data types that we've got, whereby we are saying with each of these data types we can actually be able to give a value that suits our type of variable that we might need, or the content that we want to add to each element. Okay, so we can do the initialization at this point, where we can say is equal to 5, that's our I. Then we say is equal to a decimal 3.8273. Same goes for our double. We can have it at 7.2102, and then our character remains the same as before. So we then say our character is equal to maybe an L. Okay, what this then means is we've got our variables, and these, by the way, are our primary data types. Okay, so we can put comments. We had actually not mentioned comments before, but these are our comments, whereby this is just stuff to give us what each element does. Okay, so we can have a printf. We can also do our printf in one line, whereby we are saying our I is equal to %d. We put a new line. Our f is equal to %d. We also put a new line. Our d is equal to %f. Sorry, this is not %d as well. This is now %f for our f. And then the last one is, we put a new line. We put our c is equal to %c. Okay, so the new things that we've learned in this particular program is we've added a %f. Okay, we've also added a double. We've also added a float. So what this simply means is these are different elements. So for percentage %f, that is for our decimal point data types. Okay, so it means anything that has a floating point, we work with that. Our double is a combination of two floats, okay, which simply means it will be just a double size of the float, and then our float is a decimal point value, like that. So this then becomes our double, this then becomes our float, and that's what we are working with. Okay, so as it stands, we can actually now display what this gives us, and we'll see that our program is not giving us the values that we want. One of the reasons is we did not do what we did in the previous program. In the previous program, when we assigned these values, we then called for the actual values themselves. So in this particular case, it will give us an error because we did not assign the values, or we did not represent the values in the order that they are supposed to come. So to do that, we would need to close our program. We simply put a comma there, and then we put our I, we put a comma, we put our F, we put a comma, we put our D, we put a comma, we put our C, like that. So if we can run it, we'll then be able to see the values that are there. So our I is equal to 5, that is correct. Our F is equal to 3.8273. Our D is equal to 7.210200. Our C is equal to L. So that then means our code is running as it is supposed to. Okay, so at this particular point, we can then be able to say these are our primary data types, and our data types will then evolve to more values that we'll work with in the next few lessons. But one of them would be a void, which is also a data type, which means it's a valueless data type. We also have a string data type, which contains a list of characters. Okay, and then this simply means when we're working with these data types, we'll be explaining how they work. But the problem is we can't learn them at this stage because they would involve using other concepts that we are not yet familiar with, or we have not worked with before. But at this particular point, we can just take note that they are there and we can work with them. So what this then means now is the moment that we now know that we've got a variation of data types, we can now be able to use these data types with our operators and with certain elements that we can use and know how they work. Okay, so what this then means is, for example, we can then say, if in the event that we want to now work with operators, operators are simply the following. Operators, okay, these are characters that we use to be able to manage variables or control statements. Okay, so our operators are simply as follows. We've got the basic operators, which are our arithmetic operators. So these are operators like addition, subtraction, multiplication, division. There's this one which should give us the remainder of whatever element that we are working with. So more or less, these are our arithmetic operators. So to be able to see how these work, we might need to add a few extra variables so that it does not confuse you how each element works. So we can say operators, and we do the following. So our operators will work in the following manner. We need int num1, num2, and result. Okay, so having these as the key elements will then simply be initializing them and then giving our result. So for the first one, we want addition. Which will work as follows. So we can have a printf, and our printf does the following. We would want to be able to say the result is, okay, I think this makes life easier. We put a %d, we put a new line, and then we put our results. Okay, but because we have not added anything or initialized anything, we then need to put it as follows. Results is equal to num1 plus num2, like that. But at the same time, we've done this. We have not initialized our values. So maybe how we can do it is we can simply put an enter there, and then we put int result. We also put an enter there, and we put int num2 so that we can initialize these two. So we initialize that to 5. We initialize the next one to 10, like that. So with our addition, this pretty much works. And we can initialize our result to 0 as well, so that we can be able to start from 0 for our result. So if we run it, we'll be able to see that the first result is 15, which is 10 plus 5, which is correct. But I think we need to also give results for addition. Okay. That then becomes the first element. To do the next element, we just copy this, we paste it, we change and say this becomes subtraction. We subtract that, and then this also changes to subtraction. That. So if we run it, we'll be able to see that the result for addition is 15, the result for subtraction is 5. The next one is we want to get the result for multiplication. We just copy and paste that, and we change this bit, multiplication, and then we multiply num1 and num2. If we run it, we'll be able to get the multiplication. Although in the case of division now, we may get an error, but hopefully not, because 10 divided by 5 should give us a result, so we should be fine. So let's do division as the last element. If we run it, Oh, we didn't change the value. Okay, let's just change the values. I've gone too fast there. So we also want to change this operator and put it as that. Okay, so yes, we've got our result for addition, our result for subtraction, our result for multiplication and division. We actually didn't change this part. Let's just change that quickly. I can just copy this simply and paste it there. We've got one more operator that we didn't work with. I think let's just do okay, now everything is fine. The last operator that we need to work with is the percentage sign. I think we call it a modulus. I would have to verify. I think in the next lesson I can give you modulus. I can give you the proper answer if I'm wrong. So we put it like that. Yes, so we've got it correctly. So this then becomes the use of our operators, which are our mathematical operators, which is the first one is addition, the next one is subtraction, the next one is multiplication, the next one is division, the last one is modulus. So modulus gives us the remainder, or the value that remains between two values. So I think as at now, let me just correct this and we put it as modulus. We run it again so that at least it shows us what we've got, and perfect. We've got a working modulus, a working division, a working multiplication, a working subtraction, and a working addition. So continue with these operators and variables in the next lesson.